Today I would like to explain about system of forces. In it, first, what is system? System means it is the space or place where some process is taking place. One space here, example, where some process is taking place. It is called system. Okay, place. And this line is called boundary line. Outside the boundary, it is called surroundings. Surroundings. Okay, so if some thermal process is taking place in this space or place, it is called thermal system. If mechanical process is taking place, it is called mechanical system. If some chemical reactions are taking place in this gap, in this place, it is called chemical system. Okay, here we are taking system of forces. Inside this we are taking some forces. Okay, like this. For example, I am taking one system. In it, I am taking example concurrent force system. All forces are acting at a same point. It is called concurrent forces. Or line of action of all taken forces is same. Line of action is same point. It is called concurrent force system. Okay, this is system of forces. Now here we are taking force. What is the meaning of force? Force means it is the action which tends to move the object from one point to another point. Here I am taking one object. Okay, now I am applying some force on it. What we are taking force, it is the action. Because of this action, object is moving from this position to first position to, it is coming after applying force, it is coming here in the second position. Without this force, it will not move to the other position. It is at the same point. Okay, at the same position. Now how to define the force? It is the action which tends to change the position or change the state of rest of the object at which it is applying. Okay, now here how to define the force? Let us assume I am taking one force at C point. It is acting in this direction, some 10 Newton force. What is the magnitude of this force? It is 10. In which direction it is acting? It is right side. At which point it is acting? At C point. Okay, so these are the specifications of any force. Accordingly, we can mark the given diagram. Now here three main specifications of this force. One is magnitude. So how much magnitude it has? 10 newtons. Next is second one. Which direction it is acting? It is acting in right side direction. And what is the point of application of force? Point of application of force. Application of force. At which point it is applying? At C point. Like that we can find out the given force. Okay, now here I am taking another example. I am taking this point, some B point. I am taking vertical force, some F is equal to 30 newtons. What is the magnitude of this force? Is equal to 30 newtons. 30 newtons. What is the direction? It is upward direction. At point of application of this force, at which point it is acting? At B point. Okay, these three are the specifications of the force. Okay, one example I am taking. Here I am taking one object. I am applying some force here, some 10 Newton force. Obviously it is moving in this direction. Okay, now this is the horizontal component. Now I am applying some force here in the opposite direction, 5 newtons. In which direction it is moving? Now also it is moving in this direction because its magnitude is more compared to this magnitude. Now how many horizontal component it has? Two horizontal components. One is this side. I am taking this side is positive component, and whatever acting in this side, it is negative component. Okay, now here if you are taking resultant, how much unbalanced force is acting? So sigma Fh, sum of all horizontal component, is equal to, this is positive 10, this is negative minus 5 newtons. Okay, now resultant force is 5 newtons. If we do the resultant diagram, the diagram is coming like this. So 5 newtons positive means in this direction, 5 newtons. Okay, for getting equilibrium or constant position of this object, means it should not move, means we have to apply in opposite direction. Okay, so at that time it is in equilibrium condition. Equilibrium is it should be at constant state or state of rest is 0. Okay, now if we do the equilibrium diagram, here for the same thing, 5 newtons this side, 5 newtons this side for getting the equilibrium. Okay, now how to find this sigma fh, means all horizontal components should 0. This side we are taking positive values 5, this side we are taking minus 5 minus 5 means 0. So what is the equilibrium condition? Sigma fh is 0. Now I am taking in the box sigma fh is 0. This is one of the condition for getting the equilibrium of a taken object which is subjected to number of horizontal forces. Now in case of vertical forces, what is the condition for the equilibrium? Okay, we will see now. Here I am taking one example. One object I am taking. Now I am applying some vertical component here, 5 newtons. In the downward I am taking 10 newton force. In which direction it is moving? This is the example. Obviously it is moving in the downward direction. Now how to find the resultant? I am taking upward direction positive, downward direction negative. Okay. Now here sigma Fv I am taking sum of all vertical forces plus 5 upward minus 10 downward. How much we will get? Minus 5. Okay. So here how to do the resultant diagram? Resultant diagram is here. If you are taking the resultant, I am taking the resultant diagram at this point, so minus 5 newtons, minus 5 newton in downward direction. So this is the resultant diagram, means object will move in downward direction. So for taking this is in equilibrium condition, we need to apply 5 newtons in upward direction. Okay, so this is the equilibrium diagram, means it should not move up either upward or downward. Now what are the condition for getting the vertical component in equilibrium? Is sigma Fv is equal to plus 5 upward direction minus 5, it is equal to 0. Now what is the condition for the equilibrium? Sigma Fe is 0. Now in case of vertical components, for getting this in equilibrium, sigma Fe should be 0. In case of previously horizontal component also, the condition for equilibrium is sigma Fh is 0. Sigma Fh is 0. Now these two are the condition for getting the equilibrium. We did the practically whatever conditions are there, it is the it should follow this rule, means all unbalanced forces, vertical forces should be 0, all horizontal forces should be 0. Okay, let us discuss about concurrent force system. In this system, whatever forces are acting, those are concurrent forces, means all forces are acting at a single point. That point name either B, C, D, any alphabet. Now here for example I am taking concurrent forces F1, F2, F3 from any direction to any direction like this. Okay, all line of action of forces should be meeting at the same point. This system is called, this system means it is the place is called concurrent force system. Okay, here I am taking two forces. For example I am taking in concurrent force at capital A point. One force is acting 10 newtons. The another force is acting in the vertical position 20 newtons. Okay, 20 newtons and 10 newtons. How to find the resultant of this force? Okay, if only horizontal components are there, we can do the sum. Okay, if only vertical components are there, we can do sigma Fe. If two components are there, 10 newtons and 20 newtons, how to find the resultant of this? So here we have to consider this is sigma Fh is 0, sigma Fe is 0. We have two conditions already we have proved. Sigma Fh is 0 and sigma Fe is 0. Now these are the conditions. Now what is sigma Fh component here? Only one component, 10 newtons. What is the vertical component? Sigma Fe 20 newtons. Now here if I do the right angle triangle, because this will give the right angle triangle, this is horizontal component is 10 newtons. Okay, this value will indicate here. This is the 20 newtons. 10 newtons, 20 newtons. So according to the triangular law, if these are the adjacent sides of the triangle, the diagonal will give the result. Resultant is equal to root of 10 square horizontal component whole square plus vertical component whole square. Okay, whatever value is coming, it is the resultant. Okay, and at which angle it is acting? Resultant. So resultant is root of 500. Okay, so which angle it is acting with the horizontal means if you are taking this is alpha, we know these two components, we can take tan alpha is equal to 20 newtons by 10. So alpha is equal to, therefore alpha is equal to tan inverse of 2. Now the final diagram should be like this. R is equal to root of 500. This is tan inverse of 2. Okay, now this is a vertical component, this is the horizontal component. Now this value we need to add in the opposite direction for getting the equilibrium. We will see this type of. Now here I am taking another example which is more than 3 forces. I am taking one horizontal component 10 newtons, here 20 newtons, here some 30 newtons. Okay, so the diagram should be, we are taking like this, 10 newtons horizontal component, vertical component is 20, and then inclined component is 30. This angle is, let us assume, some 20 degrees with the horizontal. Now here how to find the resultant of force? If we have horizontal component and vertical component, we can directly use this formula. Resultant is root of this side square plus this side square. Now here there are 3 components. Okay, so let us assume sigma Fh first. Sigma Fh has one component. Sigma F is 20 newtons. What about this inclined force? Now here I am taking, instead of these two, I am taking only 30 newtons initially. 30 newtons. Okay, I am making this in terms of right angle triangle. Okay. Now for inclined force, always remember there are 2 components. One is horizontal component, one is vertical component. Okay, if you are taking right angle triangle, this is 20 degrees. We need to find this value and this value. This is acting in first coordinate. So sigma Fh is also acting here. Positive value. Sigma Fv. This we can indicate here. Okay. Now here how to find vertical component. Okay. V1 I am taking. This is H1. Now how to find this value? This is 30. We took already here 30 newtons. Okay, now here V1. So how to find out cos 20? First horizontal component H1 by 30. Okay, H1 is equal to 30 into cos 20. By using the calculator we will get this value. Okay, we get the horizontal component. Always remember, whenever horizontal component is coming, cos will come. Okay, the given value into cos the given angle. Okay, and we have to find vertical component. From the same triangle, sin 20 is equal to V1 by 30. V1 is equal to 30 sin 20. Okay, now here there are 2 components of this inclined force. One is horizontal component, it is acting here. One is vertical component, it is acting here. Why we are taking in the first coordinate means this 30 is acting in the third coordinate. Now take the all components here. Here I am taking, this is the, let us assume A point. A here I am taking. What is the first horizontal force? 10 newtons. What is the 30 horizontal force? 30 cos 20. What is the vertical component already acting directly? 20 newtons. What is the 30 vertical component? 30 sin 20. It is positive. So what we did here? We are taking this inclined force into 2 components, horizontal component, vertical component. Now here we are dividing this into only horizontal and vertical component. This method is called resolution of forces. Resolution of forces means dividing the forces, given forces, inclined forces, into horizontal components and vertical components. Now here we have to apply rules for the equilibrium condition. What are the equilibrium conditions? Already we have proven sigma Fh is 0 and sigma Fe is 0. Okay. Now here apply first condition. Sigma Fh is 0. Sigma Fh is equal to, what are the components? This side I am taking positive and this side is negative forces, and upward I am taking positive forces. Downward values I am taking negative. Okay. Now here sigma Fh, both components are acting in the same direction. So both are plus. First 10 newtons plus 30 cos 20. Okay. Now this is sigma Fh. We will get some value here. Okay, by using calci, 10 plus 30 cos 20. Now this value is the horizontal component. And similarly sigma Fe. What are the vertical components? These two are. Both are in upward direction. Upward direction means positive. 20 plus 30 sine 20. So by using calci we will get this value also. Okay, by using these two values, sigma Fh and sigma Fv, how to find the resultant? Already we know the formula. Sigma Fh is Fh whole square plus sigma Fv whole square. Okay, so substitute these two values, we will get some value is the resultant force. Okay, now here at what angle it is making is, if we are thinking it is making some phi angle, if we are taking right angle triangle, this is the sigma Fh, sigma Fv. If I am taking this is the resultant, we need to find this angle. Tan alpha is equal to sigma Fv by sigma Fh. Okay, we need to take phi is equal to tan inverse of this value, sigma Fv value by sigma Fh. By using calci we will get this phi angle. Okay, we had to write here. This is the condition for solving the concurrent force problems in case of inclined components. We will see some more examples in next classes.